vector addition, what happens when you add two vectors? Let us see the physical meaning of adding two vectors. For example, if you have a box, a person is pushing the box from this direction. What will happen? The box will go in this direction. Fine. But what if he is not pushing in this direction? But what if another person pushes the box in this direction? The box will go in this direction. Okay, fine. That is also fine. Now, what if both the persons push the box at the same time in the two directions? Will the box go in the upward direction or in this direction? The answer for that is very simple. You know the answer by just imagining it. So it's very intuitive. The box will definitely go in a cross direction, right? So the box will go in this direction because there are two forces acting in different directions. So the resultant force will act on the body and will try to push the body in the green color path. Why is that happening? And how do we know that? Because of our intuition. Our intuition says that the box will go in this direction. So we have seen for a simple case. Now let us generalize this and we'll see a general rule for adding two vectors. The first rule is triangular law of vector addition. Okay, what does triangular law of vector addition mean? For example, it says that if I have a vector like this and another vector like this, let us call this vector to be vector B and this to be vector A. The resultant vector R can be obtained by joining the tail of the first vector to the head of the second vector. That is, first we have to keep the second vector on top of the head of the first vector. Okay, we have to keep the tail of a second vector on top of the head of the first vector. So after keeping that, just join the tail of the first vector to the head of the second vector. So let us do that. So this will give us the resultant vector. So this is nothing but the resultant vector R, where R is nothing but A vector plus B vector. So this is what triangular law of vector addition says. So basically, if you have two vectors and this is how they behave when they are acting simultaneously. This is a general rule for vector addition and it can easily explain how this box moves. But we need to find the exact way or exact formula for finding the magnitude and direction of the resultant vector. If I know the magnitude and direction of the individual vectors which we are adding, we need to find a way of finding the magnitude and the direction of the resultant vector. For that, we have something called as parallelogram law of addition, but that is not completely different from triangular law of addition. It is just a different way of looking at the triangular law of addition. So let us see what is parallelogram law of addition. In parallelogram law of vector addition, let us have a vector called as vector A and another vector called as vector B. So in this method, we are keeping the tails of the two vectors at a common point. So we are not keeping the tail of the first vector on the head of the second vector. No, we are not doing that. We are keeping the tail of both vectors at a single point. After doing this, what we have to do is we have to draw parallel lines from the heads of the two vectors parallel to the other vector. From the head of the B vector, I have to draw a parallel line which is parallel to the A vector like this. I hope this is a line. Now I have to draw a parallel line from the head of the A vector which is parallel to B vector like this. Now the parallelogram law of addition says that if you join the common tail point to the intersection of these two lines here, if you join this point and this point, you'll get the resultant vector. Let's do that. So this gives you the resultant vector and this is nothing but R vector. So very easy. What's the difference between this law and triangular law of addition? Basically nothing. It's just a different view of the same thing. For example, if you take the B vector and move it to here, can you see the similarity between this law and this law? Both are same. So this is nothing but the triangular law of addition. I'm keeping the tail of the second vector on the head of the first vector and getting the same resultant. There is no much difference between parallelogram law of vector addition and triangular law of vector addition. But in parallelogram law of vector addition, we can find the magnitude and direction of the resultant vector in a more quantitative way. So let us do that. Let me first extend this A vector's path like this, and let me drop a perpendicular from this point. Before that, I'll name every point here. I'll name this point to be O, this point to be A, this B and C. From C, let me drop a perpendicular to the yellow color line. I'll call this point as D. Let us take the angle between the vector A and vector B to be theta. So if this angle is theta, then this angle is also theta, corresponding angles. Now let us proceed for finding the magnitude of the resultant vector R. So let us call the magnitude of the resultant vector R to be R itself. So R equals to what? That is the question. Consider triangle OCD. In triangle OCD, is this a right angle triangle? Yes, it's a right angle triangle. So let us use Pythagoras theorem. Pythagoras theorem tells us that OC square equals to OD square plus CD square. Hypotenuse square equals to the sum of the squares of the sides, other two sides. Therefore, if I know what is OD and what is CD, can I find OC? Because here OC is my R, the resultant vector's magnitude, because we have assumed that OC as the resultant vector, right? And we know that the length of the arrow mark corresponds to the magnitude of the vector. So OC is nothing but the magnitude of R vector. Now if I find what is OD and what is CD, my question is done. How to find OD and how to find CD? If you see carefully, OD is nothing but OA plus AD. So therefore, OD here is nothing but, first of all, let us call this equation to be equation number 1. So OD is nothing but OA plus AD. I know what is OA. OA is the A vector. So the magnitude of A vector is the length of OA. So I know OA to be equal to A. Fine. I'm taking the magnitude of A vector to be A, small a. So if I find AD, then OD is done. Now our objective is to find AD and CD, because if I find these two, then I can easily find OC. So how to find AD and how to find CD? If you see carefully, AD and CD both are parts of the triangle ACD. So now let us consider triangle ACD. Consider triangle ACD. In triangle ACD, what is this? AC is equal to OB, because this is a parallelogram, opposite sides are equal. So therefore, I can take AC to be the magnitude of B vector, and I can write AC to be equal to B itself. Okay, now we know what is AC. AC is B vector itself. So AC is the magnitude of B vector, and we can write what is sine theta in that triangle and what is cos theta in that triangle. I am drawing a rough diagram of the triangle again. This is theta, this is A, C and D. So what is sine theta? Opposite by hypotenuse. Opposite of theta is CD. Hypotenuse is AC. So it is CD by AC, and the cos theta is AD by AC, adjacent by hypotenuse. So it is AD by AC. So this implies CD equals to AC sin theta and AD equals to AC cos theta, and we know that AC equals to B, okay, the magnitude of B vector. So that implies CD is nothing but B sin theta and AD is nothing but B cos theta. So now we have found CD and AD. Now we can input these two values in the previous equations which we saw. So for example, if I have to find OD, I needed the value of AD, right? Because OD was equal to OA plus AD. So OA, I know it's A vector's magnitude A, plus AD is nothing but B cos theta, and we wanted CD and directly we got CD to be B sin theta. So now let us proceed to finding the value of OC, that is the R vector. So R square equals to OD square plus CD square. That implies R equals to root of OD square plus CD square. R equals to root of, what is OD? OD is A plus B cos theta. So it's A plus B cos theta the whole square plus CD is B sin theta. So B sin theta the whole square. So upon expanding this, I expand this using A plus B the whole square formula. So that will give me R equals to root of A square plus B square cos square theta plus 2AB cos theta plus squaring this will give me B square sin square theta. Okay, now take a look at these two parts of the equation, this one and this one. If I take B square out of these two terms, will I get cos square theta plus sin square theta? So how can I write that? R equals to root of A square plus B square. I am taking B square out of these two terms. That will give me cos square theta plus sin square theta plus this 2AB remains unchanged. 2AB cos theta. What is cos square theta plus sin square theta? It is equal to 1. So this becomes 1. That implies R is nothing but root of A square plus B square plus 2AB cos theta. So we have found the equation to find the magnitude of the resultant vector. So what we need to find the magnitude of resultant vector? We need the magnitude of the two vectors A and B and the angle between them, that is theta. So if I know what is A and what is B and what is the angle theta between them, I can use these three things to find the resultant vector's magnitude, and this is also called as law of cosine. Now we have found the magnitude of the resultant vector, but a vector has a magnitude as well as a direction, right? We need to find the direction as well. Okay, now let us think how to find the direction. So whenever, for example, if you are standing at a road, imagine that this is a road and this is a shop, okay, and a person is standing here and asking you how to go to the shop. Okay, what will you say? This is the road, so take 30 degrees from the road and walk for 10 meters so that you will arrive at the shop. So what we are saying, we are taking a reference line, and from that reference line we are saying turn 30 degrees and go. So to mention a direction, we need a reference line. From that reference line, we are telling an angle so that we can exactly point out to the direction. So what we need here, we need a reference line, and from that reference line we need an angle to represent a direction. So similarly, in our case also, we have a reference line already. We can take either B as the reference line or vector A as the reference line. So if I take vector A as the reference line, then this angle between the resultant vector and the vector A, I'll call this as alpha. Then the value of angle alpha can be easily found. If I find the value of angle alpha, then it is effectively the direction of the vector R, because I can always say, if you know the vector A, then from vector A turn alpha angle and you will be in the direction of the resultant vector. I can say that. So therefore, how to find angle alpha? To do that, consider triangle OCD again. In triangle OCD, let us see. In triangle OCD, what is tan alpha? Let us check out. Tan alpha is opposite by adjacent. So since OCD is a right angle triangle, so tan alpha is CD by OD. Do I know what is CD? Yes. We found CD to be equal to B sin theta and OD to be equal to A plus B cos theta. So therefore, tan alpha is nothing but B sin theta plus A plus B cos theta. So let us write that B sin theta by A plus B cos theta. So here also, to find the direction of the resultant vector, that is alpha, we only need A, B and the angle between them, theta. That's it. So if I know the magnitudes of the two vectors and the angle between them, I can find the magnitude of the resultant vector as well as the direction of the resultant vector. Very simple. Now let's see an example. Let us have two vectors A and B, and I have given the magnitude of A and magnitude of B here, and the angle between them, let it be 60 degrees. Let's try to find the magnitude and direction of the resultant vector. So R is given by root of A square plus B square plus 2AB cos theta. The direction formula is given as tan alpha, and our objective is to find the value of alpha. So tan alpha equals to B sin theta divided by A plus B cos theta. Let's use these two formulas to find the value of R and alpha. So R becomes root of 10 square plus 8 square plus 2 into 10 into 8 into cos 60, and tan alpha becomes 8 into sin 60 divided by 10 plus 8 cos 60. Let's solve this quickly. R equals to 100 plus 64 plus 2 into 80 into cos 60 is 1 by 2. So this 2 and this 2 will get cancelled. And here tan alpha equals to 8 into sin 60 is root 3 by 2 divided by 10 plus 8 into cos 60 is 1 by 2. So here you can cancel this 2 and 8 for 4. So finally R becomes root of 100 plus 80 plus 64. That will be 244, and tan alpha becomes 4 root 3 by 14, because 10 plus 4 14, that's nothing but 2 root 3 by 7. We can leave R value to be root of 244 units, or we can find the value of root of 244 exactly, but that's not required. You can leave it at this point. And tan alpha is given as 2 root 3 by 7. This implies alpha is nothing but tan inverse of 2 root 3 by 7. Tan inverse just simply means that at this value of tan, what is the angle that we have to input for the tan. Okay, that's it. And this is how you perform the vector addition using the two formulas that we just derived. If you are having any doubts regarding any concept, just leave it in the comments, and I'll try to reply to everything. And if you haven't done yet, click the subscribe button for more such content.